Hi friends, how are you? Due to the effect of the corona through over the world, critical situation has been arised. So my request to all my friend to please stay at home to discontinue the chain of the coronavirus, and the government provided some rules and some instructions should obviously follow the instructions provided by the government for our safety and to protect our nation. Thank you friend to hear my advice. Today our discussing topic is about harmonics. So what is harmonics? Harmonics are unwanted high frequency which superimposed on fundamental waveform, creating a distorted waveform. So we all know that if we put some voltage, so sinusoidal waveform has been formed in the oscilloscope or oscillators. So by help of that we can calculate the fundamental harmonics. So in AC circuit, a resistance behaves in exactly the same as it does in the DC circuit. That is, current flowing through the resistance is proportional to the voltage across it. This is because the resistor is a linear device and the voltage applied in it is a sinusoidal wave. The current flowing through it is also a sine wave, so the phase difference between two sinusoidal wave is 0. Generally, when dealing with alternating voltage and current in electrical circuit, it is assumed that there are pure and sinusoidal in shape with only one frequency value called the fundamental frequency being present. But this is not always the case. In an electrical and electronics devices or circuit that has a voltage current characteristics which is not linear, that is, the current flowing through it is not proportional to the applied voltage. The alternating waveform associated with the device will be different to a greater and lesser extent to those of an ideal sinusoidal wave. This type of waveform are commonly referred to as non-sinusoidal or complex waveform. These complex waveforms are generated by common electrical devices such as iron cord, inductors, switching transformers, electronics ballast in fluorescent light, and other such heavily inductive load, as well as the output voltage and current waveform of AC alternator and generator and other such electrical machine. The result is that the current waveform may not be sinusoidal even though the voltage waveform is. Also, most electronics power supply switching circuits such as rectifier, silicon control rectifier, that is SCR, power transistor, power converter and other such solid state switches which cut and chop the power supply sinusoidal waveform to control the motor power or to convert the sinusoidal AC voltage or AC supply to DC. This switching circuit tends to draw current only at the peak value of the AC supply, and since the switching current waveform is non-sinusoidal, the resulting load current is said to contain the harmonics. So non-sinusoidal complex waveform are constituted by adding together a series of sine wave frequencies known as harmonics, and harmonics is the generalized term used to describe the distortion of a sinusoidal waveform by waveform of different frequencies. First, we have to discuss about the fundamental frequencies. By help of that, frequencies in India is 50 Hz. Throughout the world it is 60 Hz, but in India we are using the 50 Hz frequency sinusoidal wave. A fundamental waveform or the first harmonics is the sinusoidal wave that has the supply frequency. So in that sinusoidal wave we are getting this, the first wave is a 90 degree, this is the peak value of the voltage is the Vmax, this is the zero value 180 degree, 270 degrees also the peak value of the minus, negative, reverse, and this is also the 360 degrees the zero value. So it is the total complete waveform, the time period in t and the frequency is f, and this is the degree of angle deteriorations during the propagations or during the propagation of the waveform. So if we discussed about the first harmonics, second harmonics, third harmonics and fourth harmonics, then the sinusoidal wave has been distorted as like as this. This is the first harmonics and this is the second harmonics. This is the third harmonics. This is the fourth harmonics. So this is the generalized form of the harmonics formations. This is the complex waveform of the harmonics. This is the first harmonics in the blue colored line and the red color is the output waveform. In the second harmonics cases, this is the fundamental harmonics. In the case of the output, the fundamental harmonics and second harmonics also present. So the red line is the resultant waveform. In the case of the third harmonics, the blue color light is the third harmonics imposition, and that is the resultant waveform distortions. In the fourth harmonics cases, and all the fundamental harmonics and fourth harmonics present, and resultant red color line is the resultant complex waveform. The harmonic sequencing is also a most important factors during the motor operation or any electrical machine operation. So that harmonics is the frequency and sequence. The 50 Hz, then 100 Hz, 150 Hz, 200 Hz, 250 Hz, 300 Hz, 350 Hz, 400 Hz, 450 Hz. This is the frequency range, and the sequence is positive, negative, 0, positive, negative, 0, positive, negative, 0. This is the harmonic sequencing, and this sequence has the resultant or the harmonics effect. If we discussed about the positive, so this is the forward rotation, the motor will be rotated in the forward directions, and the excessive heat effect will be generated due to the harmonics. If any harmonics is present in the systems, so excessive heat will be evaporated from the systems. If in the reverse case, the motor torque problem and the 0 is the none, the voltage and current is the neutral wire causing the heating. So if we discussed about the harmonic summary, then the harmonics are the higher frequency waveform superimposed onto the fundamental frequencies, that is the frequency of the circuit, and which are sufficient to distort its wave shape. The amount of distortion applied to the fundamental wave will depend entirely on the type, quantity and the shape of the harmonics present. So the harmonics have only been around in sufficient quantities over the last few decades since the introduction of electronics drives for motor, fan, pump, power supply, switching circuits such as the rectifier, power converters and the thyristors, power controller, as well as most nonlinear electronics, fetch control load and high frequency energy saving fluorescent light. This is due mainly to the fact that the control current drawn by the load does not faithfully follow the sinusoidal supply waveform, as in the case of rectifier or power semiconductor switching circuit. Harmonics in the electrical power distribution system combine with the fundamental frequency 50 Hz or 60 Hz supply to create the distortion of the voltage and of the current waveform. This distortion creates a complex waveform made up from a number of harmonics frequencies which can have an adverse effect on electrical equipments and power line. The amount of waveform distortions present giving a complex waveform its distinctive shape is directly related to the frequencies and the magnitudes of the most dominant harmonics components, which harmonics frequencies multiply whole integrals of the fundamental frequencies. So the most dominated harmonics component are the lower order harmonics from the 2nd to the 19th, with the triplen being the host. So friends, if you are interested to show my video, please subscribe my channel and press the bell icon for more updated technical and real life video. Thank you for watching. Obviously share my video with your friends and colleagues during this pandemic situations to get some leisure time and to enhance your knowledge regarding your old memories. Thank you very much friends.